It's been a while. This is Listen to Tony with me, Anthony Olensky, episode number 1414, and it's a comeback. It's a sequel because the episode is with Vincent Hus. We did an episode back in December 2022.
For Christmas.
For Christmas, and 10 months later, we're sitting here once again. You just flew back from, you flew back from San Francisco, 2 or 3 months ago. And during the first episode, we spoke about a little bit about your childhood, how you became the person who you are right now, this entrepreneurship game, and all sorts of things, serendipity. Today, I want to chat a bit more about some aspects of the businesses that you are building today, because you're building two businesses currently at the same time.
Yes.
And I want to start off. Well, you also started doing content. You started a Substack, so a lot of things changed in the past 10 months.
Yeah.
Before we jump into that, how is the kind of V2 of being in the Valley?
Well, it was quite pleasant actually, because you now have a lot of friends. So before you don't have friends, you literally don't know anybody, and you have to be in friends-making mode all the time. And of course,
now you can actually work. It's just like
well, it's different. So one thing I did is I moved to San Francisco because like all the startups are there, and in the Bay Area everything is a little bit farther. It's more like engineering but everything is a little bit farther. So I moved to SF and got a WeWork place there. And what's fun is that
you're actually paying for WeWork?
I pay for WeWork. Yeah, some people don't, and they sneak in for free.
But why would you go into a WeWork? Like, why wouldn't you work because previously you worked at a hacker house?
Yeah, the Hacker Dojo. Yeah.
Did you get some additional funding? Now that it's like
no, the difference is that the Hacker Dojo is just something that's in Mountain View. It's like a very unique place in the Valley, and in San Francisco you don't have a hacker dojo.
Which WeWork did you go to? Like in Selma or?
I went to the one on Montgomery Street.
All right.
Yeah. So what I've been told that I still, it's kind of true, but like every WeWork has its own culture in SF. So like the pre-seed startups go to that one, the seed stage startups go there. And if you're Series A, then you go to California Street 400.
Does it also change in terms of perks? So like if you're a Series A or Series B startup, the WeWork that you're at has like unlimited beer and you have some additional perks, fucking slides, and you're living like it's kind of like a higher standard, and the pre-seed ones are just some wood desks.
Not per se. Like there's just
coffee.
Way more free space, and paradoxically, the one where
because you need an office when you're Series A.
But the one on Montgomery Street 44, I believe, is like the one which is like the one of the most popular. So WeWork charges more for that one, actually, even like for the co-working.
How can
option.
They do that though? Because when you use WeWork, like you have the app and you just use credits, and if you have all access, it doesn't really matter which one you go to, right? Unless you're actually paying for an office.
Well, they have like free tiers. So you have like global access, and then like all access. I don't know the difference. You know it better than I do.
Yeah.
But
so you just paid for that one, and it was more expensive than the other ones because you were part of the community. Okay, got it.
Yeah. But that's a shit ton of fun, because like, so number one, like in these WeWorks, it's like a completely different vibe than elsewhere. Like everybody is like, number one, everybody's doing a startup. So like you can ask, hey, what are you working on? And you make a lot of friends. People are also like very talkative to you. That was like a little bit different than let's say in London. Like,
is there like healthy competition? Like, do you actually tell people what you're doing, and they're like, okay, cool, I'm gonna try to poke holes in what you're building and try to actually push you?
I didn't know about poking holes too much. Like, yeah, I mean, you talk about business all the time, by the way. So you're discussing ideas. You say, hey, what do you think about my landing page? Hey, what do you think about my pricing? How do you approach this? How do you approach fundraising? How should I do that? Yeah, so you talk a lot about that. And you make a lot of the good friends. I think you make them like at 12 o'clock at night, when like there's less people, and you say, hey, I need to take a break. Shall we play some ping pong? Yeah. Hi, I'm Vincent. Good to meet you. And then, what are you working on? And that. And Yeah, and they start talking, and then you say, okay, hey,
When
let's
you
go
play
for
ping
beers.
pong for hours and never get back to your computer to actually work on the thing you're supposed to work on.
Yeah, exactly. No, of course you do work out, and it's also, what I really liked about about that startup. So one of the things is around the offices, there's also a lot of other startup companies or like entrepreneurs that maybe already made a few exits, and then they throw like on Tuesday dump some at fondos. Like there's a guy who is a startup fondo, and then they give like huge huge, but like large events where everybody can
Like the
come
one that
by.
in the first episode of Silicon Valley where there's Kid Rock playing and
Yeah.
yeah.
Well, that happened too. So there's this person, and nobody knows who he is, or at least like none of my friends know, but like he has like this huge house outside of San Francisco, and he's like a little bit like the Great Gatsby. Huge swimming pool, security guards.
What's
you
his
need to
name?
show your passport. Nobody knows his name. Like you're on the list, and then you get a message every 3 weeks or something, like Spice Kings throwing a party. Come there and there, and then there's like this huge mansion with like swimming pool, guards, and whatever. And none of my friends know who he is. I also don't know it. And
How do you get an invite?
I think
Do they just do they look through LinkedIn on founders who have high potential? Is there any intention behind the party? Like, do you get approached when you're there by someone saying, "Oh, I've been trying to figure out like what exactly you're building, and we have this fund."
Yeah, no. It's like I assume that he once did a startup. It's like I think this is I heard that he made an exit in a startup, and now it's like a little bit like Chris Sacca or Travis Kalanick that are just trying to vibe with founders and make friends with founders in the community. And
How do the parties look like though? Because let's say 80% of the founders are male, right? That's a stat. It's whatever. It's sad or whatever, but it's true.
yeah,
And so, is it only guys showing up over there?
no, there's a lot of girls as well.
Who are the
a lot
girls?
of Russian girls.
Okay, got it. So it's just like
No, but literally, they're yeah, of course. I mean, yeah, what you say is true. Most of there's like 80-20, I think, something like that.
But they try to keep the ratio by inviting people who are not necessarily building something, but are female.
No. I think like I don't know, but everybody is in tech. It appears though, and I don't know. I got there because one of my friends at Stanford, Artemi, who is a postdoc in AI, he got invited and he said, "Yo, do you want to join?" And then I
Plus
said,
one.
"That's great. Can I invite one friend from Holland and somebody else who I met at the WeWork in Montgomery Street, another founder friend of mine." So yeah, that's how it works a little bit. And then we were with a lot of people there, and it was a lot of fun. And yeah,
Nice. And now kind of, so you're at the WeWork, you're back in San Francisco, you kind of know how things work. You've been there before because you went there for the first time because you were in awe and you wanted to see for yourself how it looks like. But now being more of a local, we can kind of skip the whole part of like San Francisco having a lot of homeless people, all that shit. People talk about that all the time.
yeah.
Switching to the actually like the part of like what are you doing there, like doing in terms of like you mentioned landing pages, coding, etc.
Mm-hmm.
What are you building? That's the first thing, and because I know it's something in relation to bioengineering.
Yeah.
Is that correct?
Yeah. I'm working on two projects or companies. One is called Rapid RNA, which is a platform that makes it easy to do genomic sequencing analysis. So like to make it easy and fast to analyze your genomic data, with the mission to make programming in biology easier, because right now it's extremely hard.
Yeah. So I wanted to ask you about that because that's like the intersection of engineering and science and biology.
Yes. Yeah.
And is there like a cultural clash between engineers and scientists? Because it seems like scientists are driven by curiosity and engineers are driven by actually building something. And so it's like
Well, maybe both is the same thing, but I think that both is curiosity in a way. but yeah, there is definitely a culture clash. Like for instance, for sure in biotech software, because scientists build software with with a means to a scientific end, and software engineers, build software to improve the software itself. And as a result, the software in biotech is very hard to use, not well maintained, because the scientists just make it with a specific purpose. Whereas software engineers, they really like the software and they want it, to be elegant and smooth and that's reusable and these kind of things. And so that's definitely one of that is one culture clash for sure that I've seen. Yeah.
And are you building the bio startup that you're building right now? Are you building it with a fellow engineer, or is it a scientist from Stanford?
Scientist with Tushar.
All right. Yeah.
I'm visiting him next week in Cambridge.
Nice. And so working with Tushar, like how is it working with a scientist who's kind of more seems like White Tower vibes, and then you, an entrepreneur, an engineer who just wants to build something?
Well, I wouldn't say white.
Yeah, just not kind of stereotyping, but like.
So, like it's actually quite funny. Like this week we probably I can't say who it was, but like a very senior professor in the UK, and he said to the show, "Oh, I'm so happy you are a proper computational biologist because you do and wet lab and computational biology."
What does it mean to be a computational biologist?
It means that you're the most of the biology work you do is on a computer.
Mm.
So like,
doing biology on a computer. Whoa.
Well, so like you have wet lab work, and it means that you have petri dishes,
and you play with the microscope and everything.
Exactly, and you do experiments. You do different hormones or different cells, whatever, these kind of things, or you use machines like genomic sequencing machines like Illumina or next generation sequencing technologies, and you get a shit ton of data, and then you work with that data to see, hey, what's going on. And biology is transitioning more and more towards computational biology, and it's going to be more and more like that. And I like what excites me a lot is that so right now biology is very experimentally driven. We do a lot of experiments. We don't really understand what's going on, but I hope that we can go to like a more deterministic world where you can say, okay, hey, if I put this amount of gasoline in a car, I will know exactly how far it will go, and that we can do the same thing with biology. So what I mean is, right now, if you have, let's say you have a specific form of cancer, and you get a therapeutic prescribed by the doctor, it might work, it might not work, but we have completely no idea, almost. So it's a very empiricistic, statistical, non-deterministic world. And what excites me...
Even now, like, so you prescribe something and you're like, or, okay, I get that part that it's not possible to really find out how it's going to work 100%. But you're saying we're going to be able to do that?
I mean, number one is I hope we will be able to do that. And yes, I feel as well, like we're slowly moving more and more to that, because now we can correlate. Right now, we know your genomic code, and we can correlate that to diseases, to specific forms of cancer. And if you have a small mutation in your genome, we now know, okay, that's the reason. You don't have just leukemia. You have a specific one letter at, like base 2,000, 2,500,000. Is a C, but should be a G. And now we inject you with an RNA-based therapeutic to fix that, remove it, and
Got it.
I fix it.
The first thing that came to my mind was miracles in medicine. People would say like, oh, this person was like had cancer and suddenly they're like healthy, and because you couldn't really measure the impact of certain drugs, right? And because no one would say, like, when we mentioned the car example, right? A car has this amount of gasoline. When you're out of gas, the car is going to stop. There's no miracle that's gonna happen. Suddenly you're going to be able to drive 100 miles more. And so I'm curious, like, how do people, because right now I guess they cannot explain miracles in hospitals, but do you think they're gonna disappear or they're gonna still be there?
Well, what is a miracle?
I mean, you heard these stories, right? Like someone is diagnosed with some like awful tumor or some shit like this, and suddenly the tumor disappears.
Yeah. Well, again, we don't understand what's going on. So in biology, there's so much we just don't understand.
Why is
And,
that?
Why is that? Why don't we understand biology?
Because we have AI, we have like ChatGPT 4 came out this week, like the feature where you can take a photo, it's going to explain everything from the photo, and it's just like, it's magical, right? Like, and then Sam Altman posted on Reddit, I don't know if it's true or not, but like, we just achieved AGI. And I'm like, holy shit. And then like, you're telling me like, and I kind of see it also, I have friends who are in the medical field, like, yeah, there's so much stuff we still don't know.
So, well, we haven't explored it yet. So, in early 2000, I think it was 2002, was the first time that we were able to sequence a whole human genome.
What does that mean?
That means your genetic code, your DNA.
So you can take the whole...
Your whole, everything about your whole body is A's, C's, T's, and G's. And...
yeah, sorry, do you mind with the music? Hey, excuse me?
Przepraszam.
Hey, excuse me? Sorry. Okay. Sorry about this. Sorry. The music is playing on your phone.
Yeah, no worries. So what we're talking
sequencing. We sequenced the whole...
Okay, so in 2002, you had the Human Genome Project, which cost $2 billion to sequence, your whole human genome. So correlating every A, C, T, and G in your whole body, what you're made up. Now, why is it important? Because it defines everything about you, whether even, what color eyes you have, what color hair you have, if you're susceptible to a certain type of cancer, if you will maybe get this cancer, all these kind of things. Now, in the last, and that was, the huge news, but only actually 1 year ago, so they claimed victory that we had sequenced the whole human genome, but they did not even sequence the dark parts of the human genome, which were like unreachable because, so it is not just a string of A's, C's, T's, and G's. It actually has a 3D dimensional structure. And sometimes in specific places, the DNA is folded in such a way that you cannot access it. It's called a dark human genome. That was only 1 year ago. So, so we have very limited knowledge yet around, we've just have this technology to understand, what you're made of, sort of. Then the other big innovation is that is on RNA, is that we always thought that DNA goes to RNA, goes to proteins. So RNA is like the classical type of RNA is messenger RNA. So it messages like a recipe of your DNA, which should be turned into something else, like a hormone, or like maybe it should be the recipe to create blood cells or hemoglobin or anything. And what we only recently figured out in the last few years, let's say last 8 years or something, is that RNA can actually also not only be a messenger, but can also change your DNA. It can be used, it has multiple functions. It can change your DNA. So let's say you have a genetic malfunction because you had a spontaneous mutation that led to a cancer or your cells multiplying way too fast, then you can use RNA to fix that genetic malfunction and replace that letter that turned from a C to a T and refix that. And so what I want to say is we and that's only one function of the RNA, but there are so many other functions that we're just trying to figure out. We're learning. There's also parts, we are also learning that there's now new molecules that are suppressing genes that are, you have your DNA, and these molecules stick to your DNA and get placed on that so that they can't be reached. And like, there's so much we don't know. Like, even
Clearly,
so,
but like,
these COVID vaccines, right? So that's a messenger RNA product, and that's like phenomenal. And you know, what's exciting is that Moderna is now using the same technology to create cancer vaccines. You know, to if you either as a preventative cancer or as a therapeutic cancer vaccine.
but you mentioned that part of like you can find certain defects in your code, like your DNA, and then you can exchange these like the parts of the sequence that they're gonna malfunction.
Yeah.
So are we gonna make tailored vaccines to like each individual? Like gonna find this, or so basically I go get a checkup
when necessary.
Okay, because sometimes it's like it's a common thing, and they can find like, oh, certain people, their DNA has a malfunction in this area, and we're just going to produce a vaccine that's going to be tailored to this subset of the population.
Well, so there is. It only makes sense, of course, for diseases that are genetic diseases or that are related.
Did you check your genetic code? Did you like see like, oh, do you know what you have? Like what's in store for you? Do you know?
I didn't know. I didn't, but I would like to do it. But it's the costs now drop like crazy. So like now the cost of a whole human genome is like $100. So like, of course, it's probably more because of, and actually, so Illumina, you know, you sent me like this article of Illumina, which was phenomenal to read. It was super interesting. I read it like really late at night.
Substack.
Substack is the shit.
This guy's name is Elliot something, but I can put it in the show notes. But yeah.
Yeah, it was amazing. I subscribed as well. So thanks for sending through. So one of the things I was trying to figure out in the last 2 weeks is like how much genomic data is sequenced annually. And so how do you approach that? Well, so there's only one paper that was written in 2015 that tried to estimate the amount of data that's generated yearly through genomic sequencing.
That's 8 years ago.
That's 8 years ago. Yeah, I know. And Illumina is citing that paper, which is 80% market share, is citing that paper from 8 years ago, which doesn't seem entirely fair. So I did a lot of digging on this. I started posting on every forum out there, and like nobody appears to know. But I also found it not fair, and I wanted to know the answer.
Why are you using the word fair? Like it seems like it's not. Like it's just like weird that it's not.
It's just highly well. It's
are you saying they're using their market share to suppress research?
No. I'm saying that if you're believing a paper that was written 8 years ago about the state that was predicting the state of the industry in 10 years.
And now we're 10 years out.
We're 10 years out. So
something is off. It's not fair. It's unfair or fair.
It's just fucking weird. It's just bullshit.
Okay, got it.
It's just bullshit.
Okay, got it.
And so they thought that the amount of data produced annually would be between 2 and 40 exabyte in 2025. Exabyte is 1,000 petabytes, and a petabyte is 1,000 terabytes.
Okay, it's a fuckload of data. But like when you say like
so it's an exabyte is 1 million terabytes. So a terabyte is like understandable.
Got it. But yeah, the part of like genomic sequencing, like you're saying that generates a lot of data. What does the sequencing actually entail? Like what does it mean?
What sequencing entails?
Yeah, like you're saying the sequencing generating so much data. Like what does?
So you get a cell. You get a cell, and you analyze the genomic material in that cell, which is your DNA, which consists of 26 chromosomes.
So like I go to a clinic and they take part of my DNA, and you're saying that so many people do this every year. They generate so much data through that it's going to be thousands of exabytes. Or
so this is irrespective of who does it, whether it's so you have a couple areas, right? So you have diagnostics. So like let's say you feel ill and you and the doctor says, okay, let's test if you might have specific form. You have preventative, right, which is becoming very big in the US. You have also clinical trials where this is applied a lot for already people that are ill, and you make new these types of genomic medicine, or just R&D, or actually just trying to map out all the different types of species in the world and what the differences in their genes are, which is super interesting because that is why we know how we are related to apes. Or one of the interesting what's super weird, this is one of the interesting things, is that if there are certain viruses that can transfer their DNA into you, or like you also have cross species gene transfer, like through viruses. So let's say you have let's say you have a lizard and there is a virus, then hypothetically, and it happened before, that you get these lizard genes in you as well. And they might not be active genes and not might do anything, but there has been...
could they activate themselves? You're saying that if they stay in my genetic code and then like my posterity at some point might have some lizard features?
No, it's not about that. It's not per se about that, but like, so you had like evolutionologists, I don't know the right word, but people that study evolutionary theory. And basically they try to say, okay, how far back did these species have a common ancestor?
Oh shit, because they're saying that because...
But okay, so here's the thing. They could not explain it via a common ancestor. So they found through that research that cross-species gene transfers can occur through viruses. That was the point I wanted to make.
And that creates...
And that was super interesting.
And that creates all this diversity.
Well, not per se. There isn't a conclusion yet, but it's just a fact that
mutations, basically.
Yeah, mutations or transfers of... So mutation is typically just this one letter that is changed, but it can be more than that. It can be whole genes, sort of. Yeah, so this world is like so insane, and we don't know anything about it. And
that's cool. That's a theory, kind of, and I get that. But so, what are you doing about it?
Yeah, so one of the things is that programming that world is insanely hard.
Close to your mic.
So programming that world is insanely hard for a lot of reasons. So one, it's like takes a lot of time and and is very expensive. So you can launch a website on AWS or any other service like in minutes, and it's free.
Like a WordPress.
Like a WordPress, exactly. And in biotech, it costs $48 per day to rent a server, and it takes a long time to do these experiments.
Is it a special server? Like, why does it cost so much?
Well, because you can do it on your laptop, but it will just take a long time if you want to process like a meaningful amount of data.
Data coming from the genomic sequencing.
These are just very, very intensive computations. So because a whole human genome is 90 billion base pairs. Out of these machines, you get small puzzle pieces of 100 base pairs. And you have to fit them all together next to each other. And you don't know which piece should be where. And because they're so small, 190 billion is a lot. So that computation is trying to fit every single piece next to each other. Will it fit? Will it not fit? Will it not fit? It's called assembly. And that's super computationally intensive. And that is why you need a lot of computational power for it. And if you did, it's for one human. But if you do have if you have like a larger sample population, let's say of different types of cancers, and you want to see what are the common genes that they have in common, so we can identify healthy from unhealthy or different types of cancers from each other, it becomes phenomenally complicated, phenomenally expensive, and it takes a very long time. So yeah. So what does it mean? So it costs a lot of time and it's very expensive. So that reduces access. That's what you do.
But aren't the people who are already doing this, like, they have the resource? It's not like every kid or like every programmer is trying to sequence genomic data, right? It's like it costs $45 per hour. I get it, but I think the institutions that take care of it or like that do that already have the funds. And so could you make it cheaper for them? Probably, and that's maybe a worthy endeavor, but is this the best use of your time?
So this is not per se the problem that I'm focusing on. It was in the highlights of that there are like in the context of why is programming and biology so hard, and there's
Because it's
like
expensive.
it's expensive. It takes a lot of time. It's about huge amounts of data. The software is poorly documented. It's because why software engineers again there's this culture clash between scientists and software engineers, and scientists want to invent science and they don't care if their software is reusable, beautiful, and nice to use. One of the examples is you have BioPython, which is used by 400,000 users monthly. Their user experience is looks like from 20 years ago. It's like black and white, and they have 500 outstanding issues on GitHub. In the modern web application frameworks, it's not black and white. It works wonderfully. You can use it in any sub framework that you want to use. You have code examples. You have libraries. It always works. You never have an issue. It's wonderful. And in biotech, how it works is documentation is non-existent. It's 3:00 at night, and then you find buried in a comment on GitHub that the reason why your software didn't work for the last 2 days is because you used AWS Linux while the software only works on Linux Ubuntu. And it's just really difficult.
So you are gonna build like the software you mentioned that has the design is like from 20 years ago. It's clunky, 500 outstanding GitHub flag or like reports or issues. You're building something like that, but just tailored to 2023 with slick designs and a very intuitive user interface. And is that it?
Yeah, one of the things what we want to do is we want to make it super easy to create new computational biology tools and make it very easy to use them.
Who does these computations? Like, who is the target user?
So we're starting out in like any researcher that works in genomics. Actually, you have to if you have to analyze gene expressions.
But where's the money? So the university is paying, or who's paying?
No,
for
the
this?
money is in big pharma. Yeah, obviously.
Sorry.
No, because so academia doesn't have any money at all.
Yeah, that's what I was thinking. I was like, shit,
but,
like I thought you mentioned researchers, but then you're saying big pharma.
But you have to get academia on your side, because there's. So I'm talking to pharma from day one, right? And had talked to pharma all week, but also to academia. Academia has faster sales cycles, so they can use you right away. You don't have to go through procurement and these kind of things. So that's why it's half the market probably. And yeah, biotech and bioinformatics are both extremely, extremely hard, I think. And in order to win or to survive, I think you have to, you have to focus on maximizing user adoption and ensure that everybody's using.
And now you're talking to users already. You're doing the discovery phase, or you're actually trying to sell?
No, I'm doing discovery phase because, because every time that you change your assumption or the product, you have to. I'm not in the building.
What's Tushar doing? Is he building the product?
No, Tushar is also focusing on hype. Right now, we're
Tushar, the co-founder.
Yeah, Tushar is focusing on tool research, hypothesis writing, also as for me, and joining the conversations.
Okay, cool. So you guys are doing discovery. You're focusing on that. That's the first business, which is trying to create a better software for big pharma and researchers to essentially compute and like not only compute but
to make it easy to create and use computational biology tools.
Got it. What's like just like before we move on to the second business you're working on, what's like a example output out of like using these computational tools? Like what's the desired outcome?
In terms of business objectives, or in
Say
terms
like a
of
big pharma, like what do they use it for? They're using it in like drug discovery, or
no, not specifically, not in drug. Well, they're using it in diagnosis to see. Okay, hey, we know this patient is ill and they have leukemia, but what is happening on the genomic level? What kind of mutations are there?
okay, and then they dump in the data into your software, like in the ideal state, and then
Yeah, exactly.
and
Yeah.
then they can see exactly
Well,
what's
so
going
so
on.
actually not per se my software. The way I look at it is like, there's a lot of people that are creating wonderful tools, but they are just super hard to use. What we want to do is that you point at a GitHub repository, and it installs right away on any environment or your laptop. You can experiment with it. You can deploy it to a high performance cluster at your university, or to the cloud.
It's fucking weird, right? Like a lot of these issues come just from the user interface and intuition, right? Like there's so many cool tools out there, but you just need to create, like you were saying, like, oh, there are tools out there already doing this, but they're just not intuitive. We can make a slicker design.
No. But like also, it's not about the design per se, but it's also hardcore infrastructure. Like they like the environment management. Like, so the tools are highly sensitive. If you have like a different Python version or a different, or whether you use it on Mac or what version of Mac. Okay, my point is reproducibility is a huge issue in genomic sequencing analysis. If you change the conditions in where you're using the tool, the outcome might change completely.
Where being what? You mean like on which server, or?
Yeah, literally what the configuration of the server is can change the outcome of your assigned this or that.
So I can just fuck up the servers,
or that. It could decide the outcome if you have a false positive or false negative in what type of cancer you have. So it's a huge issue.
That's wild. So they
It's
can
wild,
they,
yeah.
they
I mean,
misdiagnose people just because the server was like not tuned in the right way.
So it's still all statistics, right? So it's like not did it happen? Yes. Is it going to happen? Yes. And
That's beyond me.
So that is why reproducibility is so important, and it's very, very difficult to achieve, and that's one of the issues that we're going after.
Understood. All right, so that's one thing you're willing with Tushar. Like you guys are talking to customers, potential customers, or like users, and trying to refine the product. And there's so many moving parts. Why are you building another company at the same time? And or another product? What's the other product about?
Yeah, so the other product is Netrunner, which enables you to turn your AWS account into Firebase. Firebase is, so you have the big free public clouds like AWS, Google, and Azure. Nobody likes Azure. Actually, today I was talking to somebody who used Azure. First time ever, by the way. But
shout out Microsoft.
But the developer platforms are like a joy to use. They're fantastic. Your productivity is high and it's wonderful. But they only have like 8 services, and they don't scale. We were building Voinavage, stuff started to break out. It takes such a long time to process an order. Also, your search is slowing down. All these kind of things. So that's why typically you start at the developer platforms and you move to the public clouds. But my idea is to turn your public cloud into a wonderful Firebase-like experience. And
what's Firebase though? I mean, like you're using 2 companies. You're just saying like, I want to turn like the AWS experience into a Firebase experience. What is Firebase doing?
So Firebase is a cloud platform. Imagine like AWS, but then with much deeper integrations and frameworks for what developers want to do. Okay, so an example. Okay,
So
let me give you
basically,
an example.
you have like
So
the AWS is the fundament, and like it provides you a lot of leeway in terms of like how you can tweak the cloud infrastructure, and then it's like and Firebase is like a nice layer on top of that, which allows for a lot of customization.
well, exactly. So, like develop, yeah, and you have many of them, right? So you have Firebase, you have Vercel, you have Supabase, you have Heroku.
Right, you know about Vercel now. 'Cause we spoke about it
Yeah,
last week.
exactly. Yeah.
And so what the fuck? And you're
So
trying,
Vercel uses AWS under the hood.
and so you're trying to build the same thing.
No, but like so so these what the developer platforms do is they provide a much better, wonderful experience than the public clouds, while they are running on the public clouds, and they charge a 10x premium on that. The problem with that is you only have access to those 8 specific services. Well, my idea is if well, and you cannot extend it because they pretend that that they do not run it on the public cloud. And my idea is to provide that experience, but be completely open on it and just deploy it on your own AWS account instead of their AWS account.
And doing that will change what? If you do it on your own versus on their AWS account.
Well, it will change the scalability issue for sure, the extensibility, and you're not limited to 8 services or 2 databases, but you can have any database that you want to use.
Because you can customize your own account and integrate different databases to it.
Yeah, you use extensibility. You can do whatever you want.
It seems like the second one is slightly more straightforward and there is more money in, or like at least immediate need and users. Like the first one is slightly you mentioned the amount of unknowns and like working big pharma.
Yeah, but it's about passion.
What's the first one's your passion project? Like people have, some people build like airplanes out of like cardboard or Legos, and you on your weekends try to figure out the mess in genomic sequencing, and then Monday to Friday you're working on solving DevOps problems.
I just find what's happening in genomics so fascinating. So like when I wake up, I just check fiercebiotech.com and read what's going on.
So why are you doing both then? Like if the first one is the one that gets you fired up, like are you doing the second one, the one with like the AWS Firebase, all that shit? Like are you doing it because you just want to make money?
Well, it also excites me, but it's more that biotech is so risky that I still don't know if it's viable. I only know that it excites me like crazy, and the second one is what I also like and what I can execute. And
what do your investors tell you? You know what I mean? Like at some point, like
they are not happy with me at all.
But you have a limited time and resources. Like, can't you just say, okay, I'm gonna focus 6 months just to grind out the second product, the cloud infrastructure product, and then focus on, and maybe I'm gonna get acquired, but like I'm gonna hire a bunch of people. 6 months actually it's not enough. Like you work on that for 2 years, and then you sell it to someone like, you sell it to Firebase, you sell it to Amazon. You have a nice exit, like easily, like say 200 mil, and then you do your bio.
Yeah, but I have a weird idea, and I actually, why I don't really mind doing this is because when I knew when I was building the turn your AWS account into Firebase, I knew that I was building all the required infrastructure and also interfaces that could change biotech.
Okay, so they're related.
They're unrelated, but so everything which I'm doing on Netrunner is reusable in biotech because it doesn't exist in biotech at all, like at all. So that's for sure one route why I'm happy that I'm fine that they coexist. And actually I started out in storage. Storage is one of the biggest problems in biotech. Furthermore, my reasoning for starting a Netrunner or with on storage was following these bio conversations in pharma and knowing what kind of issues they had with integrating storage into their applications. and I recognized the same things from building primary portal and processing documents and these kind of things. But I just knew the field of cloud application development much better than biotech. So that's why I started out there. But they're for sure both applicable in biotech, although my biotech pursuits are not applicable to
Man, like I think
cloud
this lack of
infrastructure.
focus can like really trip you over at some point.
For sure, yeah. It worries me also.
What are you gonna do?
I will run out of money.
You gonna
in,
see
like,
Tashar? Yeah, what's your runway?
Yeah, so I don't know by what miracle, but like it always extends. But yeah,
You calling mom? I mean,
no, like I think I don't have more than half a year for sure not.
okay.
But
See
you
you
know,
for Christmas, and we'll know.
yeah, but I you know what I'm actually not too worried, to be fair, because I mean I didn't do any fundraising in quite a while. But I know that on the biotech front, I've shipped a product to the market, so that's one good thing on the cloud infrastructure side. And then on the biotech side, we are making a lot of breakthroughs actually. Like, so
What does Tashar say?
Tushar is pretty hyped up. Like,
He's gonna leave academia. Or are you gonna make him? Which university is he at?
he's a postdoc at Cambridge University.
All right.
Which is pretty exciting because the DNA helix molecule was discovered at Cambridge. So you have in genomics, you have like 3 hubs roughly. I say 4, but you really have 3. So one is like Oxford and Cambridge, which has 4.
So you're just dumping them together, just saying United Kingdom as well.
Yeah, because they're too small on their own. Like that's the truth.
Before we go to the 2 other ones, do you have your phone on you? Just to take your time, because you don't.
I should. I put. It's there.
Cool. All right. The other 2, we got like 3 minutes left.
Okay. So, it's Oxford, Cambridge, which is like 1,500 people working in genomic sequencing analysis. And then a little bit more specified than that. Otherwise it's larger. So let's say for specific hits in LinkedIn, 1,500 people come out in Oxford, Cambridge. 3,000 in Boston, Massachusetts, or Harvard and MIT.
Yeah.
And then another 3,000 in
Stanford or whatever.
in the Silicon Valley Bay Area. So these are like the 3 hubs. And then I say 4, which is everything else, which is 10,000 in Europe, but completely dispersed, like in every country.
He's in the right spot. You're gonna go see him, and like hopefully next week you guys gonna decide like how do the next 6 months look like, because you're gonna say, hey, listen up, I have 6 months of runway left. I'm working on 2 things. I like working on this project with you, the one about genomic sequencing. But are we gonna kind of go into 6th gear and kind of try to ride that bitch out, or are we just fooling around? Like, I don't know. What are you going there with? Like, what's the approach?
Well, so for me, it's now. I wanted to come to a decision myself, now in an accelerated fashion. If there is a business here, and to if it's possible to really pull the trigger hardcore on this, because I
say less. Okay, understood.
So, but having said that, it looks like it's getting increasingly like that, and I'll have to I think it's gonna look like that. So yeah.
Nice. I guess parting question, because it's you're gonna be flying to.
Yes, I love you. What? No.
Yeah,
Okay.
Yeah. Well, like you flying to San Francisco. It's your 3rd time
yes.
going there for you're gonna stay there for a few months, I guess.
Yes.
What are you going there with in terms of like what are the expectations in your head and plans?
I have to raise
change WeWork, or
I have to raise a funding round, otherwise I'll be
so you basically the goal right now.
Yeah, I'm not gonna go to build. I'm gonna go to recruit and to fundraise.
For the first event, you're going to recruit for the genomic sequencing venture, not the database, not the database, sorry, the cloud infrastructure one.
Yes.
Well, thank you. It's lovely seeing you again.
I don't know how it's gonna pan out, but
Well, hopefully
yeah.
you'll tell us once we meet up, because we're going to see each other for Christmas, most likely.
yeah.
Yeah, good luck, dude.
Awesome. Thank you so much. It's been awesome, and I'm happy that we could talk. And it's been awesome connecting with you in Warsaw. And I hope that we soon will do like something badass, crazy.
We're going to a big party tonight. So see what happens over there. But yeah,
Awesome.
Thank you.
Great.
Cool.